Okay, how are we doing today? So we're doing module 1 of Cisco 1. So of course Cisco 1 is Introduction to Networks, and module 1 is networking today. So it's a bit of an introduction on the use of networks in the world. Okay, so the topic covers how networks affect our lives, what network components we use, network representations and topologies, so diagrams and the like, common types of networks, internet connections, reliable networks, network trends, network security, and talking about IT professionals and certification. Okay, so networks affect our lives. So communications is always as important to us as our reliance on air, water, food, and shelter. In today's world, though, the use of networks, we are connected like never before. So basically, we have no boundaries. Well, you know, we have data connection just about anywhere on the planet. And if you've got satellite, I suppose you do have it anywhere on the planet. And so we all have global communities of people with like interests and the like. And so the internet network helps us to join our human network together. So what network components do we have? So we have hosts, and so every computer on a network is called a host or an end device. And so, of course, some hosts act as servers, which are computers that provide information to end devices. So be they email servers, web servers, file servers, whatever they do. Server, they provide a service, while clients are the ones that use those services. And so clients are computers that send requests to servers to retrieve information. And so they ask a server for information like a web page or whatever it might be. And so, of course, email server runs email server software. Clients use email client software to access it. So there's a symbiotic relationship between the two. Same with a web server and a web browser. And of course, with a file server, you have a file server process and a client that also accesses those files. So we can have peer-to-peer networks, and so it is possible to have a device be a client and a server at the same time on a peer-to-peer network. This type of network design is only recommended for very small networks, so maybe at home. You know, how many people have got more than one printer at home, and so you hook that into one of your machines and you share your printer with that. The other machine might have a larger hard drive, so you store most of your files on that. And so very cheap and easy to do, and less complex, but that's with a small number of computers. But as soon as you start making it bigger than typically somewhere around 10, that's when the administration actually gets harder on these peer-to-peer networks than it does on a centralized server network. And so the beauty of the centralized server is you can do most of your administration on the server, and the clients will just pick up their settings from that server. Also, there is better security on a server or operating system, and of course the scalability is you can add more and more users and more computers, and the administrative overhead does not increase as much. So also peer-to-peers are not designed, specialized server hardware is optimized to do that job. Normal client machines are certainly not. Okay, so end devices is where a message originates from or where it is received. Data originates with an end device, flows through the network, and arrives at an end device. And so, of course, these are your end devices, all the host computers, and then, of course, all these other devices in between we call intermediary devices, which is the next slide. So an intermediary device interconnects end devices. Examples include switches, wireless access points, routers, and firewalls. Management of data as it flows through a network is also the role of an intermediary device, including to regenerate and retransmit data signals, to maintain information about what pathways exist in the network, and notify other devices of errors and communication failures. So regenerating and retransmitting data signals. So as signals move through media, they weaken or attenuate, and of course because they're digital signals, as long as they are interpretable, they can be then regenerated into full strength digital signals by these devices. So maintain information about pathways, of course, is routers exchanging routes using routing protocols. And of course, notify other devices of errors and communication failures. And so ICMP Internet Control Message Protocol will normally do that kind of stuff. All right, so network media. So communication across a network is carried through a medium which allows a message to travel from source to destination. And so the major types are copper cables, so like our Cat5, Cat6 cables that we use. Fiber optics is another option, and so glass or plastic fibers, and of course they use pulses of light instead of electricity. And of course there's wireless, which of course uses the air as a medium and sends modulated signals through the air as electromagnetic waves. Okay, so network representations and topologies. So basically, when we design a network, we often make a diagram, and so we will use all of these items as to indicate where things are positioned and the like. So the network diagrams are often called topology diagrams, use symbols to represent devices within the network. And so of course we've got the end devices here, so desktop computers, IP phones, wireless tablets, laptops, and so on. So intermediary devices, so wireless access points, multi-layer switches, normal switches, firewalls, and routers. Then of course we've got the media itself, and so normally for LAN connections we use just a straight line. For WAN connections we use the lightning bolt, and for wireless we often just use the analog signal. And so important terms to know include network interface card, physical port, and interface. Often the terms port and interface are used interchangeably, so that's all very fine. And so of course for a host to be able to connect to a network, it needs to have a NIC or network interface card of some sort. Of course, these intermediary devices you would normally think of as having a physical ports, which of course are often called interfaces. Now, topology diagrams. And so basically there's two major types of topology diagrams, so a physical topology and a logical topology. So physical tells you exactly the location in a building of where these devices are, and also where the cables run as well. So I'm going to say I don't find this diagram, the left diagram, to be particularly good in that regard, but so basically if you had a plan of your building, then you would actually just superimpose where the cables run, where the servers are sitting, where the routers are sitting, and so on and so forth. And so that's where you can physically find those devices and cables and the like. Now, logical diagram is more about how things are organized, and also about addressing scheme as well. So it's a logical way of organizing that. And so you've got looks like a server subnet here, and you've got another network here, and another one's here. So they're all separated into how they are connected, and subnets as well. Okay, so common types of networks. So basically a lot of this is all about size, and so small home networks, of course most of us have probably got a network at home, be that it's just a wireless router that everything else connects into. And so of course, you know, mum, dad, and the kids have several devices all there. Very, very simple. So a small office, home office, basically is just one step up from your normal home network. So you might have an office set up with multiple machines, and you might have specific tasks that you do. And then from there, you've got branch offices and main offices, and of course they can span cities, countries, or the planet, depending on the size of the company. And so of course they will grow accordingly as per that. And so of course when you have multiple sites, that's when you start having to use the services of a telco or an ISP or something like that to transmit your signals from one office to the next. And of course you may well have to use several ISPs or telcos if you've got a worldwide network for your company. Okay, so LANs and WANs, again we're talking about the geography. And so network infrastructure can vary greatly in terms of size of the area covered, number of users connected, number of types and services available, area of responsibility, and the two most common types of networks are a LAN and a WAN. So a local area network and a wide area network. So a local area network is normally within the one building or a group of very closely located buildings, while a wide area network could well span the city or the world, depending on the company. So a LAN, as I said, is a network infrastructure that spans a small geographical area. So the interconnect end devices in a limited area administered by a single organisation or individual provide high-speed bandwidth to internal devices. Now, another difference is with a LAN, normally the business or the people who own it own the entire network. While with a WAN, you will normally have to use the services of a telco to join them together. Not many of us get to run fiber from one site to the next. And if you do, well, it's going to cost a bit of money. And so WANs typically interconnect LANs over a wide geographical area, typically administered by one or more service providers, typically are slower than LANs because the more bandwidth you use, the more it's normally going to cost you. And so you sort of limit that speed to what's affordable. And so the internet, of course, is the ultimate of WANs. And so it's a worldwide collection of interconnected LANs and WANs. The LANs are connected to each other using the WANs. WANs may use copper, fiber optic, or wireless transmissions. So the internet is not owned by any individual or group. The following groups were developed to maintain the structure on the internet. So the IETF, ICANN, and IAB are the bodies that sort of make the rules and how things work. Okay, so when it comes to business, you can have sort of several layers of access, basically. So starting from the middle, you have an intranet, which is the internal network for the company. And so it's a private collection of LANs and WANs internal to an organisation that is meant to be accessible only to the organisation's members or others with authorisation. Now, an organisation might use an extranet to provide secure access to their network for individuals who work for a different organisation that need access to their data on the network. So this might be a company that you work with closely. So be it you share projects, or maybe you're a supplier and they're a consumer of your product, and so you have an automated ordering system or something along those lines. And so that's when you would give that company more access than the rest of the world that would have. And of course, then the internet, of course, is the rest of the world. Okay, so internet connections. So basically, there are many ways to connect users and organizations to the internet. So popular services for home users and small offices include broadband cable, broadband digital subscriber lines or DSL, wireless WANs, and mobile services. Organizations need faster connections to support IP phones, video conferencing, and data center storage. Business class interconnectors are usually provided by a service provider and may include business DSL, lease lines, and Metro Ethernet. So, home and small office connections. So cable is an option. And so basically, it's the infrastructure that was designed to, of course, send cable signals to homes so they can watch channels, but they've actually set aside some of their bandwidth for the use to connect to and from the internet. And so that is certainly a fairly decent system. A downside of it is normally you share that bandwidth to everyone else on the street. Now DSL is where basically it uses a traditional telephone line in a smarter way, and so digital subscriber line, and so you can have a fair bit of bandwidth on that. It's always on internet connection that runs over a telephone line, and so it separates the upload, the download, and the actual phone conversation typically. Other options is you can actually connect using cellular network, and so that does work nicely, but it can be a little bit expensive. The bandwidth is not as generous as your fixed connections normally. Satellite is another option when you don't have access to cable, DSL, or maybe even cellular, and so the beauty of that is it can cover huge areas of a country. The downside is that there's normally a lot of latency because that signal's traveling all the way to space and back to get to your premises. And then a last option there, an old option, is the old dial-up telephone. So it certainly is cheap, but it is very slow. And so if anyone remembers dial-up modems, they are not a quick thing. I think you'd have trouble connecting to an ISP with a dial-up modem these days, but anyway. Now, business connections can be similar-ish, but they will normally be higher in bandwidth, sometimes dedicated connections, and also you may well have managed services. So a dedicated lease line is one option. Now that's normally typically bigger businesses that want to have a dedicated circuit that goes through a telco's network. Now, of course, you're paying for the access to that 24/7, so it's not a cheap solution. Ethernet wide area networks can happen. So basically, they plug fiber into your home, and of course, you can get very large amounts of bandwidth through that. DSL. Now, of course, the DSL for homes is normally called ADSL, which is asymmetrical DSL, which means you've got more download speed than upload speed, because typically that's what home users would need. But of course, businesses may well have DSL between on two sites, and so if you're uploading from one site for another site to download, you're sort of hampered by that slower upload speed. And so symmetric DSL means you've got the same upload and download speed, and so that does work better for businesses. Of course, there has to be a specialized DSLAM in the exchange for that to happen. There at least were SDSL DSLAMs in the city in Adelaide, but I don't know if they still are. And then, of course, there is still the option of satellite. And so, again, that's normally for your remote areas that don't have the other services available, typically, again, due to that latency. Now, traditionally, back more than 20 years ago, many buildings used to have 3 networks running through them. And so you had your computer network for all your computers, and then you had a telephone network for your phones, and then you had another often coax network for video. And so they were all specialized for that, but of course you actually had 3 different technologies all running through the same building, and so you had 3 sets of skills that needed to do it. And so now basically the converging network is getting all of those 3 to run on the computer network. And so most of us probably use VoIP phones if you've got a home phone, and video, of course, runs over data networks pretty well as well. And so it's not a big job, and so then you only have one network to maintain and one set of humans to maintain it. So as I said, converged data is data, voice, and video. And so converged networks can deliver data, voice, and video of the same network infrastructure. Then that infrastructure uses the same set of rules and standards. And so basically, yeah, one network can do it all. All right, now reliable networks. That's always important, for business at least. So network architecture refers to the technologies that support the infrastructure that moves data across a network. There are 4 basic characteristics that underlying architectures need to address to meet user expectations. So there's fault tolerance, scalability, quality of service, and security. And I think the next slides will cover that. So fault tolerance, of course, is a fault-tolerant network limits the impact of a failure by limiting the number of affected devices. Multiple paths are required for this fault tolerance. And so reliable networks provide redundancy by implementing a packet switch network. Packet switching splits traffic over packets that are routed over a network. Each packet could theoretically take a different path to the destination. This is not possible with circuit switch networks, which establish that circuit before any communication happens. And so here, as you can see, you've got this router that's failed, but because we've got alternate links and alternate devices, we're able to actually reroute that traffic through this one into the rest of the world. And so, yeah, so that is a fault-tolerant design. Now, scalability means you can grow the network and add users, and it will still work well. And so you can support those new users and applications without impacting the performance and services to the existing users. And so network designers follow accepted standards and protocols in order to make networks scalable. So quality of service, again, this is actually required because we've done the converged networks, and so voice and video have different requirements than data, and so you need to have a certain quality of service for those types of traffic. And so voice and video, live video, require higher expectations for those services being delivered. Have you ever watched a live video with constant breaks and pauses? This is caused when there's a high demand for bandwidth and available, and quality of service isn't configured. Quality of service is the primary mechanism used to ensure reliable delivery of content for all users. With a QoS policy in place, the router can more easily manage the flow of data and voice traffic. And so basically, it can reorder the queues so that those delay-sensitive protocols actually experience as little delay as possible. Okay, so of course, network security is a big thing. There are two main types of network security that must be addressed. So infrastructure security, and so with that, you've got physical security as well as unauthorized access. And so then you've also got information security, so protecting the information or data transmitted over the network. And so basically, the three goals of network security, they call it CIA: confidentiality, integrity, and availability. And so confidentiality means no one else can read your data, it's private. Integrity means that you're sure that the data has not been altered. And availability, of course, means that you can reliably access that data. Okay, network trends. So recent trends, so the role of a network must adjust and continually transform in order to be able to keep up with new technologies and end user devices as they constantly come to the market. Several new networking trends that affect organizations and consumers are bring your own device, online collaboration, video communications, and cloud computing. So BYOD, or bring your own device, allows users to use their own devices, giving them more opportunities and greater flexibility. BYOD allows end users to have the freedom to use personal tools to access information and communicate using their laptops, netbooks, tablets, smartphones, and e-readers. BYOD means any device with any ownership can be used anywhere. Okay, so online collaboration. And boy, the last year we've been seeing that. So you can collaborate and work with others over the network on joint projects. Collaboration tools such as Cisco WebEx gives users a way to instantly connect and interact. Collaboration is very high priority for businesses and in education. So Cisco WebEx Teams is a multifunctional collaboration tool, so you can send instant messages, post images, and post videos and links. Okay. So cloud computing allows us to store personal files or backup our data on servers over the internet. So applications can also be accessed using the cloud and allows businesses to deliver to any device anywhere in the world. So cloud computing is made possible by data centers. Smaller companies that can't afford their own data centers lease server and storage services from larger data center organizations in the cloud. So there's four types of clouds. So there's public clouds, and so of course Microsoft supplies it, Google supplies it, Amazon provides it. There are other providers as well. And so basically the general public can use it, and a pay-per-use model is there, or for free. So of course when you pay, you normally get more storage and more services basically. With private clouds, so that's basically kept within the business or government organization, and so as the name suggests, only that organization uses it. And then there's hybrid clouds, so basically you have more than one. You might have part custom, part public. Each part remains a distinct object, but both are connected using the same architecture. And then custom clouds can be built to meet the needs of a specific industry, such as healthcare or media. They can be private or public. Okay, so what technology trends are there in the home? So smart home technology is a growing trend that allows technology to be integrated into everyday appliances, which allows them to be interconnected with other devices. Ovens might know what time to cook a meal for you by communicating with your calendar on what time you're scheduled to be home. Smart home technology is currently being developed for all rooms within a house. Another option can be power line networking. And so instead of getting Cat6 cable run through your house, you can actually use power line networking. So it allows devices to connect to the LAN where data network cables or wireless communications are not a viable option. And so using a standard power line adapter, devices can connect to the LAN wherever there is an electrical outlet by sending data on certain frequencies. Power line networking is especially useful when wireless access points cannot reach all the devices in the home. And so it's quite a cool thing. Used to be only about 2 megabits a second or something like that, but it has improved in speed greatly recently. Okay, so of course wireless broadband. In addition to DSL and cable, wireless is another option used to connect homes and small businesses to the internet. So more commonly found in rural environments, Wireless internet service providers connect subscribers to designated access points or hotspots. Wireless broadband is another solution for the home and small businesses. It uses the same cellular technology as used by a smartphone. An antenna is installed outside the house, providing wireless or wired connectivity for devices in the home. And so network security. So network security is an integral part of networking regardless of the size of the network. The network security that is implemented must take into account the environment while securing the data, but still allowing for quality of service that is expected of the network. Securing a network involves many protocols, technologies, devices, tools, and techniques in order to secure data and mitigate threats. Threat vectors might be external or internal, so meaning basically external means they have to come in through your firewall, while internal could be that you've got someone inside that's attacking, or it could be someone inside who's downloaded the wrong software and got some malware on there that's allowing remote control. So external threats, viruses, worms and Trojan horses, spyware and adware, zero-day attacks, threat actor attacks, denial of service attacks, data interception and theft, and identity theft are all external threats. Internal threats can be lost or stolen devices, accidental misuse by employees, or malicious employees, those unhappy ones. Okay, so what solutions are there? So they must be implemented in multiple layers using more than one security solution. And so the security components for home and small office networks can be things like antivirus and anti-spyware software, should be installed on all end devices, and firewall filtering is used to block unauthorized access to the network. Again, you can do that on hosts as well as the border of your network. So larger networks have additional security requirements, so you might have a dedicated firewall, access control list, intrusion prevention systems, and virtual private networks. The study of network security starts with a clear understanding of the underlying switching and routing infrastructure. Okay, so we're on to the last topic, the IT professional. So Cisco has several certifications available, and of course what we're starting today is actually moving towards the CCNA certification. And so basically it demonstrates you have a knowledge of foundational technologies and ensures you stay relevant with skills needed for the adoption of next generation technology. So the new CCNA, which is of course version 7, what we're doing is it gives you an IP foundation and on security topics as well, and it teaches you wireless, virtualization, automation, and programmability. The new DevNet certifications at the associate, specialist, and professional levels help to validate your software development skills, and then specialist certifications and validate your skills in line with your job role and interests. Okay, so what jobs? And so at netacad.com you can click careers menu and then select employment opportunities. And so you can basically find and tune employment opportunities using the Talent Bridge matching engine. Search for jobs with Cisco, Cisco partners and distributors, seeking Cisco Networking Academy students and alumni. Okay, so we've reached the end of the chapter. And so a quick rundown on what we've done is through the use of networks we are connected like never before. All computers that are connected to a network and participate directly in network communications are classified as hosts. Diagrams and networks often use symbols to represent different devices and connections that make up a network. A diagram provides an easy way to understand how devices are connected into a large network. Two types of network infrastructure are LANs and WANs, of course differentiated by geography. Small office, home office internet connections can be cable, DSL, cellular, satellite, and dial-up. Business connections can be dedicated lease line, metro Ethernet, business DSL, and satellite. Network architecture refers to the technologies that support the infrastructure and the programmed services and rules or protocols that provide data across the network, move data across the network. There are 4 basic characteristics of network architecture, so fault tolerance, scalability, quality of service, and security. And so recent trends in networking are bring your own device, online collaboration, video communications, and cloud communications. When it comes to security, there are internal and external threats to networks. Larger networks and corporate networks use antivirus, anti-spyware, firewall filtering, but they also have other security requirements. So you might have dedicated firewalls, access control lists, intrusion prevention systems, and virtual private networks. And so when it comes to certifications, what this course is aiming you towards is the CCNA, and it demonstrates your knowledge of foundational technologies. There is the logo, so that's the end of the chapter. And so we will look at chapter 2 next. Have a nice day. See you then.